So yeah, essentially, this problem statement of coming up with ideas to work on came up in uh, some of the workshops that we do, and I saw that a lot of people are struggling with coming up with concrete ideas to work on. They either are on the side of the spectrum where the idea is like super specific, or on the other side of the spectrum where the idea is completely vague. And usually most people are also stuck on one particular idea rather than, having the ability to navigate the idea space and choose what they should work on. And, since we are also building a product, generating ideas that we can explore is very important for us. And generally speaking, in product development, you want to always have a range of ideas that you have explored handy so that you can use them whenever it is necessary. So a lot of what I'm going to talk about is in the context of product development, but I don't think any of these frameworks have anything super specific about them and can generally be used everywhere, I think. All right, let's go through them. Very quickly, just to give you a context of why do you need ideas in product development. A lot of us, when we want to build a new software product, we start from programming. So we sit down and do a bunch of coding. And, sometimes that programming that we are doing is associated with some idea that we have. But that's not how it should work. It should actually work the other way around. We should always start from a range of ideas that we want to explore. And then from these ideas, come up with some mock-ups. And the purpose of these mock-ups is so that we can test our ideas and select the ones that have higher potential to go forward with. And out of those mock-ups, we create a bunch of prototypes. These are, functioning versions of our idea that are not necessarily programmed, like they could be faked. And again, like we use these prototypes to validate some of the ideas that we have. And the ideas that are validated through this stage eventually get programmed. So instead of, starting from coding, we should really start from an idea and start testing it in different stages until we get to a point that we're comfortable enough to start coding it. And obviously, once you have the code, you can productize it, and hopefully you can turn it into a business and make profits, blah, blah, blah. So that's the sort of product development frameworks that I'm talking about, starting from many ideas. And these are not random and unrelated ideas. These are ideas that are related to each other about a particular problem that you want to solve. We'll get into more details about this in a bit. But essentially, a big reason for why you work like this instead of the typical ways that people work is to de-risk working on an idea that will fail. A lot of the time, you can find leading indicators of an idea being a bad one very early on if you ask the right questions. And that's why you want to generate a lot of ideas so that some of these that are naturally going to be bad ideas and they will fail, then you're not stuck. You still have an idea that you can work on. And through each of these stages, we're just making that idea a little more real. And as we do that, we get more useful feedback from users, from stakeholders who we're interacting with, in order to turn that idea into something that can actually be used by some users. And on the top, I have the time scales of how much time you should have spent on each of these stages. Like when you're generating a lot of ideas, it shouldn't really take you more than hours to do that, because otherwise you're getting into one idea too deeply, which is risky because that might fail. And it also has the opportunity cost of working on better ideas. Then, you shouldn't spend more than days on mock-ups. Mock-ups are usually, very low fidelity versions of the idea. Like if you're building a web application, it could be literally a PowerPoint slide where you draw up what the web page would look like. Like that's literally what it is. And usually you keep it black and white to even not create distractions because you want to, explore your idea with the user. And weeks for the prototypes, like these are more high fidelity versions, month for programming, etc., etc. And again, like all of these are to reduce the risk of working on something that would fail. And if I want to put other names on these, like you're doing discovery in earlier stages, you're doing short-term validation by prototyping and programming, and eventually you have a product and business and profit, hopefully. And these are all, long-term validation kind of work that you're doing. I don't know what this is. Yeah, so yeah, and essentially you do this for any product feature that you have, like when you're coming up with your product idea at the very beginning and go through it as you go. And as I mentioned, the purpose of having the type of mindset that I talked about is so that you can validate good ideas. But in reality, what you really want to do is invalidate bad ideas. And the way you do that is, through the stages of discovery, short-term validation and long-term validation, is that you figure out what you want to do, you write down the assumptions that you have about them, and you come up with a validation plan. Then you do research about your idea, you learn a bunch of stuff, and you repeat this until you narrow down to the idea that you should work on. In the validation plan, you usually need artifacts, or you have to design experiments. And these are like literal artifacts and experiments. Like sometimes you want to decide if the users need a new feature on the website. So you design an experiment, for example, you show that feature, you show a mock-up of that feature to the user, to some users, and show it without to some other users, and then collect data to see which one is driving more conversion or whatever you're trying to achieve. So things like low fidelity mockups that we talked about are examples of artifacts, or it could be literally an engineered solution that you have on your website or some other medium that you're working in. And learning comes in different flavors too, in different stages. Like it could be a qualitative learning. For example, you could be interviewing some potential users to get some qualitative data. Like I don't know, like some people here were talking about quantum just now. Say if I have an idea related to a quantum computer, if I think people in finance would be able to use it, the very first thing that I do in discovery is to go sit down with people in finance and understand, can they actually use the quantum computer? And obviously in short-term validation, you want to move on to quantitative data because that's more scalable, etc. And once you have your engineered solution, obviously you want to collect data on large scale so that you can use it to refine your future ideas even better. And this is something that we use internally for any sort of problem size. It could be the grand strategic plans that we have for the company, all the way to something as simple as where should this button be on the website. So now let's get into, okay, before I go forward, maybe I pause here and let anybody who has any questions to ask before I go forward, because it's important to be on the same page about these. Any questions so far? You can just unmute yourself and ask, I guess.
Yeah, okay, so you follow this framework. What kind of things would indicate that you've invalidated the idea?
Yeah, so that's part of your validation plan, right? So when you're coming up with your validation plan, it's like any other experiment design. So you decide that, I don't know, I'm going to talk to 10 people, and if 7 out of 10 tell me that they're interested in this idea, then that's an idea that is validated, at least in the current phase. Then you just move on to the next phase, etc., etc. The thing is that that's a very good question, because I'm calling it invalidation, but the reality is that it's not a black and white scenario kind of thing. It is always, regardless of you validating an idea or not, the important thing is that you learn something. And based on that learning, you design your next iteration. And this is a very, very iterative process.
Okay, thanks.
No problem. Any other questions?
So, Amir, what's an ideal sample of your research group?
I'm actually going to show some examples. Let's wait for it. Actually, Jiri, since you're here, you have gone through this framework for the last workshop. Do you have any learnings from this that you want to share quickly?
My learning would be actually that, and it's something you even emphasized before that you may find things you didn't expect it before. So something that's maybe obvious to you, some people may find very not very straightforward, and also you may learn what people actually want, something you haven't considered before.
No, 100%. That's something that I experience on a weekly basis, that I assume that something is fantastic. And I talk to a bunch of people and they're like, either they don't understand it at all, or they understand it, but they're like, nah, I don't care really. So that's a very, very interesting point. And, you know, that's how you can understand the value of this framework, because I could have gone on for several months to program this thing, make it super shiny, and then show it to anyone, at which point they would be like, I don't care. Then I would have wasted, you know, 4 months, 5 months on it. But with a very simple, you know, mock-up, which is like literally a PowerPoint slide that I created in half an hour, I can get the same information very easily. Which again, doesn't mean that you shouldn't build it. It just means that the people that you talk to don't care about it. So you either find people that do, or you modify your idea a bit to be a better idea.
Actually, Amir, I have another question. So, I mean, presumably the idea you're trying to explore, it's something you want to make money out of eventually, but here you are going around talking to all of these different people. Are there any concerns that these people will run away with your idea?
There are many nuances in that question. Usually the people that you're talking to are the users of your idea. So they're not necessarily people who are equipped financially or technically, et cetera, to just grab your idea and build it. Well, I mean, okay, there's always that danger, but it is very unlikely. That's the short answer to that question. You could also, you know, you could also talk about these to other people that could actually build what you want. But, you know, they usually say, you know, it is probably 99.999% of scenarios fine, because they don't care about the idea as much as you do. And ideas don't turn into money that easily because of the process that I mentioned. Like, you really have to iterate on the idea so many times until you get to money. And the people that go through that iteration faster and more effectively are the ones who will get to money, rather than, you know, anybody who hears your idea.
Okay. Yeah, that's interesting. Thanks.
No problem. I mean, that's one of the typical things that, you know, investors ask founders, that, oh, okay, I think Google can easily make this in 2 months. Why aren't they making it? And they're, you know, Google, they can build whatever they want, but in most cases, it's just not their priority. They're building a bunch of other things that they don't care about your cute little idea. But the thing is that it is your job to prove them wrong and show them that this is an important idea that needs to be implemented. And it is not just a cute side project that you want to do. And the only way that that will happen is through the iterations and really building out your idea. Okay, so I sort of kind of accidentally came up with a framework. It wasn't actually my idea. I just randomly saw it somewhere. And much later, and I fell in love with it because it is such a good framework. And many months later, I learned that it is called Abstraction Ladder. So I'm going to introduce that concept. I used to call it the so what framework. You can use this framework in a lot of contexts, not only what I'm about to tell you. These are the reasons why you would use this framework. First, so that you can articulate what you want to do and why. Second, so that you can identify the assumptions behind your idea. And third, so that you can prioritize the work that you're doing. Okay, how does it work? The way it works is that you write down what you want to work on. Like, I'll give you an example later, but let's go through it for now. And then you ask yourself, so what? So let's say I want to write an application that recognizes how happy people are based on the image of their face. So that's what I want to do. That's the idea. Then I ask myself, so what? And I write down the answer. And then I read that answer and ask myself, so what? And write down the answer. And you just keep repeating this 3 to 5 times. And the reason that this is very powerful is that it allows you to get to the fundamental reason why you want to do something. It is abstracting away from the initial idea that you had. And what that means is that you get to a fundamental reason for what you want to do. And that's very powerful because if you know that fundamental reason, that will allow you to expand out to many more ideas as we will see. So let's go through an example. Say my problem statement is we want to build, I say what? So what is a common pest detector for who? Farmers. And it's important to write it like this because I want to identify what I want to do and who I want to do it for. So I ask myself, so what? Like, why do I want to do this? So that they can identify if their crop is infected as quickly as possible. Then I ask myself, okay, why do they want to know this? So that they can tackle the issue as soon as possible and focus on the parts of the crop that are infected. So why do they want this? So that they can only apply pesticide to the parts that need it rather than the whole crop. So why? So that they can reduce the amount of chemicals used, time spent, and cost of keeping their crop healthy. Why? So that they can save cost and improve the efficiency of their crop and reduce environmental hazards. So as you can see, from something that was kind of a solution, it wasn't even, a problem statement. It was just a, cute little idea that I had. I came all the way to the fundamental reason. So the reason that farmers might potentially want something like this is that farmers care about saving cost, they care about the efficiency of their crop, and they want, hopefully, to reduce environmental hazards. So what this allowed me to do is to go deeper into understanding why I wanted to do this. And when I say why, it is from the viewpoint of the user that I'm building this for. And this is a very challenging exercise. A lot of the time when I'm doing this with people or I'm doing it myself, I get stuck in the third layer because beyond that, it's very hard to imagine it. So sometimes you have to talk to somebody who is an expert on the topic or, do a bit of Googling to figure out why do they care about this at all. But, it is really good if you go 3 to 5 layers down because then you get to a problem statement that is, it is abstract, a lot more abstract than what you started, but then it is easier for you to say why you want to do this because remember the first one. Now I can articulate why what I want to do and why. And the way I would do it is that I talk about this fundamental reason that I want to build this. Then I'm giving context about why I want to build this, and people will understand it. And obviously, the so what is, one version of it where you're exploring the reason you want to build something, but you could also use a very similar framework to talk about the urgency of why this should happen now. I'm not going to go through it, but very similar idea. And one thing that is very important to remember is what I have down here when this slide goes away, is that a lot of the things that you write in the so what exercise are assumptions. Like they're not things that are necessarily real, and those are things that you have to validate over time. And ideally, when you're validating each of these statements, you have to back them up by stats. Like you have to find numbers about them. Like if you say, I don't know, like the farmers care about saving cost, you have to be able to come up with, okay, how much is their cost? How much of it can they realistically save? You should do this exercise from the viewpoint of the user. You have to say why the user wants this rather than why you want this, in most cases, when you're building a product. Okay, so as I mentioned, I'm just going to summarize very quickly. What we did is essentially creating an abstraction ladder. The original idea was this. I want to build a common pest detector for farmers. I can ask myself how to become more concrete. So if I ask myself how once on this original statement, then it would be like, we would do this by building a leaf image classifier. So this is a more concrete idea. And I get to this by asking myself how, or I would ask myself why and get to more abstract ideas, like what we did in the previous slide. Yeah, as I said, that's a more concrete idea. On the abstraction ladder, the very bottom step or layer is the very fundamental reason or very abstract problem that you want to solve. And that's sort of the mission of what you're working on. So your mission with whatever you end up building is this. You have only one of it. Like this should not change, because if you change this, then you're working on a very different problem. But the concrete idea is a realization of how you can potentially solve that problem. And in principle, you want many ideas like this. You want many concrete ideas like this that will potentially solve that problem.
So is the assumption that, let's say I come up with this idea, I'm like, whatever, just going for a walk and I get this brainstorm, like we want to build a common pest detector for farmers. Is the assumption that deep down inside, I know that it's because I want the farmers to save cost and improve the efficiency of their crops? Or is it just like, we just have these random ideas and now this framework is a way to generate maybe more similar ideas, but it doesn't like necessarily rely on the fact that we knew what the underlying motivation was?
Yeah, I think there are several parts to your question, so I'm going to try to answer them separately. So one is, we have not yet generated new ideas. All we have done so far is abstracting away the problem that you want to solve, and there are multiple reasons for it, like because you want to know why you want to solve this problem, etc., etc. So we are still working on one idea, like we haven't really expanded yet. You don't necessarily know why you want to do this. And that's why, as you build this abstraction layer, it is very likely that you need to talk to users. Like you might be able to do one pass of this, but there's no guarantee that what you wrote is right. And a lot of these, as I said, are assumptions. So you go talk to farmers in this example, and then you learn, oh, actually, the reason that they care about pests on their leaves is X and Y and Z, which is none of this. So you have to rebuild this. So you reiterate on this until you know, okay, this is the reason they want it. That's either talking to farmers or some experts that know farmers very well. or, Googling is probably the most, handy way you can do it. But ideally, it should be directly talking to the end user to understand, do they have this problem?
So I guess my question is, why wouldn't you just go, like, why do you need to go through the process of having this idea and then going through the abstraction ladder? Why wouldn't you just like go talk to some farmers and find out what problems they have?
Oh, 100%. Like that's what practically that's what you'll end up doing. Like the reality is that you never go to a farmer and say, tell me all the problems that you have in the universe, and I'm going to figure out which one I want to solve. You always have some initial hunch. And that's how you get from your initial hunch to an abstract problem from which you generate all the ideas you can work on.
So how many questions of so what one should ask generally?
Typically, we do around 5. Like we sort of really try to do 5 because like it is completely subjective. At some point, whenever you're satisfied with how abstract the problem statement is, that's good enough. But usually we push ourselves to do 5 because in our experience, that's just like beyond 3 is difficult. It really challenges the assumptions that you're making. Up to 3 is usually pretty easy. But then when you're trying to do the 4th one, it really makes you think like, okay, why am I doing this at all? And that makes you research, go talk to people, etc., etc.
So in this case, we came from a concrete idea to a more fundamental reason, right? Let's say if you know the reason you want to do something and you want to change something, let's say, and you said there can be multiple concrete ideas. So is there a reverse for abstraction ladder?
Yeah. So here, it's completely arbitrary that I started sort of towards the more concrete ideas. Sometimes my initial idea can be a more abstract idea. So the way I build the abstraction ladder is by asking myself how a few times instead of why a few times. But in principle, you want to have a ladder that has, I don't know, 5 layers probably around the idea that you originally had. Okay, so far, what we've done is to go from an initial hunch that you had that, oh, this is an interesting problem to work on. And you sort of abstracted that away and created your abstraction ladder, which means that you got into a fundamental problem that you want to solve. And now you want to generate a list of ideas that you can work on, which is not only the first thing that came to mind, but rather you want to have a range of ideas to select from. But you don't want to do it in a way that the ideas end up being completely unrelated to each other. You want to generate a list of related ideas to the fundamental problem that you wanted to solve. Those ideas are not necessarily like they can be different aspects of the problem, but fundamentally, like if you build the abstraction ladder for any of those concrete ideas, it should get to the same fundamental reason. And the way you do that is the following. So you grab your abstraction ladder. There's a mission, which is your very abstract problem statement. And then as you go up, things become less abstract and eventually more concrete. So this is the abstraction ladder. You select one of these ideas. Like you don't have to go all the way to your mission. Like you just do a gut feeling or whatever else way that you can. You select one of these layers. Ideally, relatively abstract. Let's say I select this as my very abstract idea. Then remember how we go up this ladder. We ask ourselves how. So I'm going to ask myself how once, and that will give me the idea that I already had. Then I'm going to ask myself how else, and that is going to give me another idea. So this idea is a new idea that I didn't have before. But in principle, if I ask myself, why do I want to do this? I should get to the same reason. And in principle, these two should be as mutually exclusive as possible. Like this should not be a reframing of this problem or, a subsection of this problem. This should be as much as possible, really, how else can I solve this problem? And you literally continue doing this. So every time you grab one of these, ask yourself, how else can I do it? Like in this example, I get to the original idea, but then I create also 3 ideas that are on the same level of abstraction, but they are mutually exclusive compared to this one. And then I repeat it until I get to a range of ideas that are concrete by asking myself how and how else. And I'm doing a fraction of 2 here, like a division of 2, but in principle, you can do this as many divisions as you need. But very interesting, in 3 layers with a division of 2, I got from my very abstract idea to 8 relatively concrete ideas. And each of them have the abstraction ladder that gets to the same fundamental question that I'm trying to tackle. And this is something that is time consuming because it requires you to know about the problem. So sometimes you might get stuck. You might have to do research or talk to users, et cetera, et cetera. But in principle, this is how you go from your fundamental problem to a bunch of concrete ideas. And the way you do this is to, and you do it this way because that ensures that all of the concrete ideas are related to the most fundamental problem that you had. Let's look at an example for our farmers. So let's say the very fundamental problem statement that we want to have is we want to have a targeted application of pesticides. So how do we achieve this? By tackling infection as soon as possible. So this is like a temporal aspect of this problem, or pick the right pesticide or dosage. So this is like a very different idea than the original one that I had. But thinking about, I want to do this, oh, maybe I could do this instead. And then for tackling the infection as soon as possible, I can notify the farmer when and where the crop is infected, or I can predict where the infection might happen. So again, 2 different ideas. Like this is more looking into the past and current state. This is predicting the future. Then about this one, I can identify the type or severity of the infection, or I can provide a list of inventory of pesticides that are available to each farm. And I just keep going up. But you can see that, originally I only had, this idea, this idea. But now I generated all of these extra ideas by going to the fundamental problem that I wanted to solve and then coming back up and generating all these ideas. So now instead of the abstraction ladder, we have an abstraction tree, and there are a bunch of ideas that we can work on. So what are the advantages of this? I'm not stuck on the first thing that came to mind. I had to do some research to build this, so I understand the problem much better. So I understand all the aspects of this problem that are involved. One of these ideas might be a lot more impactful than what came to mind initially, or a lot more feasible given the data that I need, et cetera, or the interest of the farmer. So the fact that I have all of this list means that I can research a wider range of ideas and then select the one that I should build. And generally speaking, as I guess we briefly talked about at the beginning, a successful product that you build is usually out of iterations. And iterations means that you're validating assumptions in every step. And some of these assumptions might be so risky, and you end up learning that what you thought is not valid. So your whole idea will be significantly blocked by that problem. And at that point, you do so-called pivot. So you pivot your idea to something that is fairly different than what you originally thought. But the fact that you've gone through this exercise means that, let's say if I pick, I don't know, this one to go further and then get blocked, the fact that I know so much about other aspects of the problem means that I can make a more insightful pivot into one of the other ideas that I have, because I know about them, and out of the failure of this idea, I learned something that tells me, oh, actually, this is the right thing to go forward with, and that enhances your ability to select the right thing to pivot to. So this is also a very important point. This exercise is most effective if you do it as a group, because when you do this exercise as a group, you can in principle bring in a bunch of people who are a lot more familiar with the problem than you. Like if you are talking about car sales, you could bring in literally a bunch of car dealers to sit down with you and ideate through this problem. Or you could bring in a few people who are in the market for a new car as your potential users, and have some sort of focus group. Like you have the structure. Like what you start is that you don't show them, like let's say you brought in a bunch of farmers and a bunch of people that work with farmers, let's say suppliers of pesticides, etc. You don't show them any of the tree. You just show them the problem statement and say, how can we solve this problem? They start throwing out ideas. You start documenting. You start building the tree. And at each layer, you grab the ideas, you write these two, and then say, okay, let's focus on this one now. How can we solve this? Bunch of ideas comes out, you group them, create these two. Same on the other side. And then you end up with all the concrete ideas at the end. It is extremely effective. That's how we usually do it. Like we bring in a bunch of people that we think have something to say about the problem, and just without any priming, like we don't give them any information because we don't want them to get stuck on a particular aspect. Give them the abstract problem and say, go, just figure out how we can do this. Everyone throws out idea, we group them together, and we form them into these problem statements. And then we go layer by layer and end up with a bunch of concrete ideas. What we did was that we started from a very abstract problem statement, then we were groups of 6 or 7, and we just essentially just did ideation. Like each person literally rapid fire write down anything that comes to mind. And I even asked people to try to come up with 20% crazy ideas. Like, don't worry about feasibility, we figured that out later, just put down all the ideas. Then we grouped them and wrote problem statements for each of them. And then we used, a chart like this to decide which of the ideas we want to take forward. So this is impact versus feasibility. And at each layer, we decided which problems we want to go deeper into, and did the same thing again and again until, we built this tree, which just starts from our very abstract problem statement. We came up with a bunch of ideas. These two were the ones that we selected to go further. And then we kept repeating this, and we ended up with, like 20 ideas that we can explore. So, what I described is not theory. It just happens in reality very nicely. And, this top list that are all the ideas that we can explore now are way more than what we originally were thinking about. And they capture many different aspects of the problem that we were not, that were not on the top of the mind initially. But now we know that we can essentially tackle any or all of these problems eventually.